Okay, here is another example of the quadratic area problems. I hope that these will help you to solve all the problems like this in ALEKS and kind of see the pattern of how these problems work. They are pretty complicated problems, so you probably need to see a couple examples to really get it. Okay, so this is another one taken directly from ALEKS. It says a school wishes to enclose its rectangular playground using 240 meters of fencing. Okay, once again, when you're doing the fencing, that is called the perimeter. It's that distance around the thing. Suppose that a side length in meters is x as shown. So they're calling that x, so we know that this is x. We don't know the other sides of the rectangle, so we're going to call those y. Okay, so now we can write an equation for the perimeter, and we could say, well, 2x plus 2y, that's adding up all the sides, is equal to 240. And then we're going to do the same thing that we did before. We know we are eventually going to want equations only in terms of x. We don't want x and y. So we're going to solve for this y. Okay. The first thing we want to do is subtract 2x from both sides. So we get 2y equals 240 minus 2x. Okay. Now to get y by itself, we're going to divide both sides by 2. So that's y equals 240 divided by 2 sounds like 120. And then that would be minus x because you're going to divide each term by 2. All right, so we're going to use this later in the problem. If you have questions like this on your quiz, I hope you can see that you cannot just give an answer, but this would be a problem where you would be expected to write out work and then submit it on Blackboard, right? Because you can't do these problems with just an answer. You need to write out the work. Even I'm writing out the work and I'm the math teacher. All right, so the area of this playground, right? You know that area, let's switch colors here. Area is equal to base times height. And so in this case, the area is y times x, or x times y. But we don't want to have the y in there. So this is the part that we're going to substitute for the 120 minus x. So the a of x is equal to 120 minus x times x. Okay, so when we simplify this a little bit to put in our answer, it's going to be 120x minus x squared. Okay, so that's what we would put here, 120x minus x squared, and that represents the area in terms of the side length. What side length x gives the maximum area? Okay, so once again, we're looking for that maximum area, and then if you look at this equation, this is where I want you to start seeing the pattern. These are kind of all the same. This is a downward facing parabola again, right? This is a quadratic, so it's going to look something like this somewhere, and it's going to be, since it's negative x squared, this is the maximum, and we call that, for a parabola, we call that the vertex. Okay, so we are again finding the vertex. So to find the vertex, let's scoot this a little bit so you can see better. A little bit. Oh, way too far. Come on. There. Okay. All right. So to find the vertex of a parabola, we can just use h is equal to negative b over 2a. Okay. So let's write down what a and b are for our equation. So we're looking at this equation. Okay. The a is always next to the x squared, so that in this case is negative 1. The b is always next to the x term, so that is positive 120. So the h coordinate of the vertex is negative 120 divided by 2 times negative 1. Okay, so that will equal 60. Okay, there is our answer for part B. It is 60 meters. That is the x coordinate of the vertex, that h value, and so that tells us, where the maximum is. And then it says what is the maximum, so that's the y coordinate, right? So now we're looking for the k value. So the k value, just plug it into the formula. So the area, a of x, which is the a this time of 60, okay, is equal to 120 x, so times 60, and then minus 60 squared. Okay, so we're going to type that in our calculator. I'm going to bring over my very fancy calculator. And that was the last problem we did. I'll just clear that. And then it's 120 times 60 minus 60 squared. Okay. Oh, look, no, that's right. 120 times 60. Okay, that looks good. Okay, so I got 3,600. Okay, so that equals 3,600. Since it's area, it's going to be meters squared. And you know what, this got a little bit cut off, but it did say square meters there, or meters squared. So the maximum area is 3,600 square meters. Okay, I hope that these two examples helped you with this section a lot, and I hope you see the pattern in how to solve them now. Please let me know if you have any further questions on these problems. Just, send me an email, and I will be happy to help you more.